We know that solving a system of equations can lead us to a couple of special case results. The first being an inconsistent system, meaning there are no solutions, or the other case where we have a dependent system, meaning there are infinite solutions. So in our next two examples, what we want to do is look at how these two situations would arise, or how we would determine through our matrix methods that we have one of these situations occurring. Looking at example 10, we can see that we have a case we haven't encountered yet, where our first step isn't taken care of for us. Row 1, column 1, in this case, isn't a 1, so we need to start off by making that the case. So we'll update row 1 by taking 1/2 times all of our values in row 1. This will change our first row to be 1, -1, 1, and 1/2. And our remaining rows will be unchanged. Once we have that taken care of, we can look at zeroing out the values below it in one step. To do that, we'll update row 2 by taking -6 times our values in row 1 plus row 2, and then update row 3 by taking 2 times our values in row 1 plus our values in row 3. So that will zero out all of the values below that 1 that we just created. And update both rows 2 and 3. Now our goal is to get row 2, column 2 to be a 1. In this case, I'm going to again take advantage of trading the places of two rows. So that again, I can turn this value in row 2, column 2 into a 1 without introducing fractions. To do that, we'll update row 2 by taking -1 times all our values in row 2. The 0 at the beginning will remain unchanged, but the rest of this row will update to be 1, 3, -2. Our next step will be to zero out the 13 in row 3. And we can do that by updating row 3 by taking -13 times our values in row 2 and adding that to row 3. This will give us 1, -1, 1, and 1/2 in row 1, 0, 1, and 3 in row 2. The first entry in row 3 will remain unchanged, but that second entry will become a 0. The third entry will also become a 0, and then our -3 will become -23. So translating this third equation, translating that third row back into an equation would give us 0 times z, or just 0, is equal to -23, which is clearly a false statement. So what we have are all of the variable coefficients in our last row set equal to 0, and then we have some non-zero value on the right-hand side. So essentially this is like that idea of all of our variables canceling out, but being left with a false statement. So in this case we have no solution, or the other way to say that is this is an inconsistent system. there is no ordered triple xyz that will make all three of these equations true.